Moon phase data. I can predict and identify lunar phases based on the percentage of the moon that's illuminated. For our starter, the X represents the location of a person standing on Earth. Number one, describe the relationship between the three objects. So, the relationship between the Earth, the Moon, and the Sun. Well, the Earth does a counterclockwise revolution around the Sun. The Moon does a counterclockwise revolution around the Earth. Earth also rotates. It spins once on its axis every 24 hours. Number two, is it night or day for the person at position X? So if you're on position X, it's the rotation, the spin that causes day and night. So the side of the Earth that's facing the sun is experiencing day. So you would be experiencing day at position X, and the places that are not facing the sun would be experiencing night. Number three, what phase of the moon would the person view? So here, if you're at position X and you look up at the night sky and view the moon, you would be viewing a new moon where there's 0% illumination, because the side of the moon that's being illuminated is the backside, the side we can't see. We're seeing total blackness. What season is the northern hemisphere experiencing? Explain. So seasons depend on the tilt. So here you can see that the northern hemisphere above the equator is tilted towards the sun, so they're experiencing summer. The southern hemisphere below the equator is tilted away from the sun, so they would be experiencing winter. Moon phase brain dump. Every two moon phases takes about 7 days. So to go from here to here is 7 days. Here to here, 7 days. Here to here, 7 days. Here to here, 7 days. It takes the moon 1 month to do a revolution around the Earth. There's 4 weeks in a month. So when we do our brain dump for our moon phases, we want to snuff our moon phases first. So we start with the sun, that's what your S stands for. Then your new moon is when the moon is in between the earth and the sun. If you're on the earth and you look up at the moon, you see 0% illumination. It's black. Earth is here, and then your full moon is behind the earth. So we snuffed SNEF, our phases. We want to go counterclockwise to do our revolution around the earth. So we gradually grow in illumination until we're full. That's called waxing. Then, when we're 100% illuminated, we wane. We lose that illumination on the right hand side. So let's start. So after a new moon, we start to wax and we start to grow a little bit in illumination. We call this a waxing crescent. Waxing because, again, we're growing in illumination, and crescent because of that shape. Then we grow a little bit more. We are now half illuminated, so we're first quarter. First quarter because it took 1 week. Grow a little more in illumination. We're still waxing, and that's more than half, so we call that a gibbous shape. So waxing gibbous. And then from a waxing gibbous, we have a full moon. Remember, a full moon is behind the earth. That's why we're seeing 100% of illumination. We're getting all the sun's rays on that side of the moon. Now we're going to wane. We're going to lose illumination on the right-hand side of the moon. We lose a little bit at a time until we're new again. So we're losing light on right, so we're a waning gibbous. waning because we're losing in gibbous because of the shape. Here we're at a third quarter where we're losing half the light on the right, and then we lose a little more light on the right, and we are a waning crescent. And I forgot to label my new moon, which is perfectly fine because then we start all over again. So these are your 8 phases of the moon. We wax, we grow light on the right, and then we wane. We lose that light on the right. Remember, your crescent shapes come before and after a new moon. Your gibbous shapes come before and after a full moon. All right, let's take some notes. Rotation and revolution of the moon. The moon rotates on its axis every 29.5 days. The moon revolves around the Earth once every 27.3 days. Rotation and revolution of the moon. Because the moon's rotation and revolution times are so close, the moon appears to us on Earth to always show the same side. We never get to view the far side from Earth. Moon phases. The moon shines because sunlight is reflected off its surface. Because the sun's light strikes the moon at different angles and our position changes, the light we can see reflected from the moon increases and decreases. The differing amounts of light we view are called phases. The phases of the moon change gradually over 29.5 days. The key phases of the moon are new moon, first quarter, full moon, last quarter, or sometimes referred to as third quarter. If the light is increasing, the moon is said to be waxing. Decreasing light is referred to waning. And here is a little app that can tell us exactly what today's moon is. So if we click on there, we can see that tonight's moon is in a third quarter. So it's about 60%, it's a little more than half illuminated. And then we can see our dates of illumination. February 1st, it was 84%. So that sounds like a gibbous. Okay, and then we can scroll down here and we can see our percent illumination. When we hardly have any, we're back at a new moon, right? And then when we increase in illumination, we would be a full moon. So at the end of the month, the end of February, we can expect a full moon. Pretty cool. So that was the moon of San Antonio. So for our connection today, we're going to look at percent illumination. So let me just move over here so we can view our slides a little bit better. Okay, so what we're going to do here is we're going to use this table and the percentage of illumination data from the graph and drag and drop the corresponding 8 phases with the percent illumination. So what we want to do is look at day 1 on the graph. Okay, and here it's a little difficult to see on these slides, but if this is day 6 here, we can expect day 1 to be right here. Day 1, 2, 3, 4, 5, 6, and so forth until we're at a full month. So this is the percent of the moon illuminated. When we're at 100% illumination, we know we have a full moon. When we don't have any illumination, we know we're at a new moon. Okay, so we know that we wax until we're full and then we wane until we're new again. And then we're going to wax again and start the process over. So we want to know the moon phase during day 1. So day 1, if we go up here, we see 75%. Okay, that means we're almost a full moon. So that would be a waxing gibbous, right? So we're about 75% full. So what we would do, we'd come over here for day 1. And we would want a waxing gibbous so that we'd have light on the right, and we're almost full, right? So I drag that over, and then our estimated percent of illumination would be around 80% according to that graph. And now if we look at day 6, I'm going to scroll over. And day 6, I'm going to go up, and you can see we're at 100% illumination. So we can say we're at a full moon there on day 6. So a full moon is 100% illumination. So I'm going to drag that over there. So we want the phase here and then percent illumination. Let's look at day 10. So here's day 12. So I'm just going to go backwards. 12, 11, 10. So here I was full, but now I'm waning. So I lose just a little light. So day 10, I would say that we are a waning gibbous. We're losing just a little light on the right. So if we're losing just a little light on the right, looks like this. We're losing just a little light on the right, and we can say we're about 80 again, aren't we? Because we're those gibbuses. Here we were a gibbous. Okay, and here we're a gibbous, so that's 80 and 80, okay? Let's look at day 13. 12, 13. So I was losing light, losing light. Day 13 is about here. I'd say we're about 50% here. So half of the moon is illuminated, but we're waning, so we're a third quarter where we lose light on the right. It looks like we're kind of going in order here too, as you can see. So we go full and then we start to lose. Let's look at day 16. So if this is 18, I'm going to go backwards. 18, 17, 16. Losing a little more light, I'm waning. I would be a waning crescent, right? So let me scroll over here. We lose a little more light on the right. And we're a waning crescent, which is about 25, okay, percent illuminated. Day 20, let's hop over. So day 18, day 19, day 20, 0% illumination. So we would be a new moon, right? And that would be 0% illumination. All right, 2 more left. Let's scroll over to day 23. So here's day 24. So day 23 would be here. We're waxing again until we're full. So this would be a waxing crescent, right? Where we gain light on the right. So we're going to gain light on the right. We're about 15% illuminated. And then we're going to grow an illumination on the, that one doesn't make sense. Let me see here. Okay, I might have the wrong shape there, or it needs to be turned around. No, it's here. We have to swap these guys. So if I lose, I'm going to lose a little more light on the right. Sorry about that. And then I lose more light on the right, and then I knew. I gain the light on the right a little bit, gain the light a little bit more, so I am half. Okay. So what I want to explain to you is that your major phases, like a full moon and a new moon, are only lasting 1 to 2 days. Your in-between phases, like your crescents and your gibbuses, they last in between 3 to 5 days. Remember, to go from one major phase to the next is about 7 days. Well, I hope that was helpful.